अस्सलाम वालेकुम डियर स्टूडेंट्स। तो आज का जो हमारा टॉपिक है दैट इज इलेक्ट्रिक फील्ड ऑफ डाइपोल मोमेंट। So we are considering here a system of charges within this region of space, and we want to calculate this electric field at some point P, which is located at a distance of r naught. And if we assume some dipole within this region at a distance of r a from the center, and we can write them. So initially हमने assume करना है कि the total charge within the system will be zero. So we know that the potential of the field at large distance. So the potential of the field will be, so that we can write as, okay. So this is the dipole and this is the distance from the center to the point where we want to calculate this electric field. Okay. Or you can rewrite this as, so this will be equal to, because when you differentiate this with respect to r naught, it will be minus 1 by r square. So minus 1 by r square, so this will be plus, and you can write this as r naught divided by r naught cube. So ये हमने already किया है, so the potential at large distances from the center of the system of charges, right? Or you can write this as, so this will be equal to, okay, okay. So this will be, because one r naught will ये cancel हो जाएगा इसके साथ, so this will be d dot n divided by r naught square, okay, because you can write that, or that n cap r naught will be equal, that will be equal to r zero, okay. So this will be the potential. Now you can calculate, because we have to calculate this electric field of this dipole moment. So we know that the field intensity can be written as, that will be minus nebula of phi, okay, or you can write this as, okay, or you can rewrite this term as, and write some I, and this will be, okay, or you can rewrite this here. In like this you can write J, and this will be R0 J. Okay, so because you need to differentiate it, so this, अगर हम इसको differentiate करेंगे, you need to differentiate with respect to I, here it is J. Right? Now you can rewrite this term as, so this will be that minus dj, right? So let us differentiate this term. or E is that's equal to minus dj. Now you differentiate this. So first term will be that will be or not cube and okay. So this case. Or you can rewrite this term as so this will be equal to or not cube and first term will be delta ij and this will be equal to or not raised power 5. Okay, and this is that three times. Okay, so because when you differentiate, this will be minus r naught raised power minus 3, so that will be minus 3 by r naught raised power 4, and I am writing here r naught multiply, so this will be r naught raised power 5. So this is same. Or you can rewrite this term as okay. Or when you put I equal to j here, so this term will be this chronicle data. This will be equal to 1. Okay, or you can write this as minus dj, or you can minus d, because I equal to j, you can write di also d by r naught. Because in I equal to j, so this is di you can write, so you can write simply dy r naught. Okay, and second term will be that will be equal to plus 3 dj or 0 j by this is the electric field. Okay, or this will be equal to, let's rewrite this term as E will be equal to, so that will be equal to 3 into so this is the electric field intensity at some point P जो हमने already देखा था, right? Uh, okay, so now instead of that, now if you write now, or you can rewrite this term as, let me rewrite this in terms of that unit vector. So because we have that R vector is n cap R, okay, then electric field will be equal to, so that will be equal to 3 into B dot n cap upon. तो तो यहाँ पे मैंने क्या किया, I will substitute that instead of that R naught as n cap R. So this R naught vector here, okay. So this R naught vector is, that is n cap R naught. So R naught into square, तो दो इसमें cancel हो जाएगा, it will be R naught cube here, and this will be D dot L into N cap, okay. So this is the total electric field, and N is a unit vector which is along R naught. So that means this N cap is a unit vector which is along that R naught, which is the distance of the point where we want to find the electric field, right? So हमने already देखा था, we have that system of charges and we want to calculate at this point P, and this is the direction of that unit. Okay, so this was RA and this was that R naught minus R, and the total distance this was R. And this unit vector is it is directly around this point while we want to calculate this electric field. Okay. Now, so if we assume that, let's assume that, so let's consider one more case. Let us assume now we assume that now this dipole is oriented along this z direction. Okay, so that means if we want here, so this will be our z cap, and this is the direction of the dipole, and this will be d cos theta, and this will be d sine. Okay, and this is x direction. Okay, now so we assume here that if the dipole is oriented along this z direction, right? So that means the axis of the diagonal. Okay, so then this unit vector will be, so this n cap will be equal to, so this will be equal to that, or you can write that first that this d will be equal to, so the components of this dipole will be, that is 0 into comma d. Okay, or you can write this as also this unit vector. So unit vector will be, it will be that sine theta cos, because this is the cos component and this is sine component, right? Now what will be our n dot e here? So this will be equal to cos, because uh, that is a mod and mod this d cos here, right? But this unit vector, it has, it's for unit length, so mod n will be equal to 1, so this will be d cos theta. Okay. Now let's calculate the electric field intensity. So we already know, that E of z, so that is equal to, so from our earlier expression, so this is 3 n cap d dot n cap तो अगर हम, if you check the earlier expression, where it was that 3n dn by r naught cube minus d by r, so you can combine these two terms, in the denominator you have r naught cube. Okay, so this is the electric field intensity which is aligned along the z direction. Okay, so or you can derive this as, so this will be equal to, so that 3, this will be nz, and d dot n will be equal to d cos theta minus d upon r. Okay, okay. You can rewrite this as, so this is the easy form. And if you want to calculate now the electric field along the x component of this, so this x component. So if you want to calculate this field, the x component of this electric field intensity, so that will be 3 nx d sin theta, sorry, d cos theta. Okay, because you don't have that this component only, so you have to feed along, let's say along the x direction will be, that is 2 nx d cos theta, because n dot d will be again d cos theta, and there are no this component z component, so this will be minus 0, right, divided by r naught q. So these are the x and this electric field intensity along x and this z direction, right? And similarly, if you want to check in spherical polar coordinates, so अगर हम इनको, if you want to calculate this in spherical polar coordinates, so in spherical polar coordinates, so if you want to calculate this in, okay, so in spherical polar coordinates, so what means electric field intensity? So that means you need to write that nebula in terms of that. Huh? So we already know that E equal to, that's equal to minus nebula. Okay. So for spherical polar coordinates, so आपको nebula लिखना है spherical polar coordinates, right? So for spherical polar coordinates, this nebula will be equal to, that will be that r cap partial by partial r plus theta cap 1 by r partial by partial. Okay. So what is now er? Right? Okay. So that will be equal to minus partial by partial r naught of phi. Okay. So phi we have already calculated. So you just check your notes. Check on software what is the value of this phi. So this will be equal to minus partial by partial r naught, and this will be minus d, that is, okay, or you can write this as, so this will be equal to, so if you write this as, this will be r naught by r naught square, so you can write this as, because this is okay, let me write this as, this will be minus partial by partial r naught, or this is d dot n by r naught. Okay, so now you differentiate this, so this d dot n will be, so हमने already calculate किया what is d dot n, d dot n cap, so that's equal to d cos theta, right? So this will be, er will be equal to, so that is minus d cos theta partial by partial r naught 1 by r naught, right? Or this will be equal to 2d cos theta, right? So this will be 2d cos theta by r. So this is the radar component of that electric field intensity in spherical polar coordinates. So similarly, we can also calculate this E theta component, right? So we need to calculate now what is E theta. So E theta will be equal to, so that will be d sine theta. Okay, so sorry. So this will be equal to that 1 by r partial by partial theta. Okay, so let's calculate this. So E theta will be equal to, that will be equal to 1 by r, and this phi will be equal to, that is d dot r naught on r naught. Okay, and this will be equal to 1 by r r naught square. Okay, because you can add this n cap r, so r naught 1 एक इसके साथ cancel हो जाएगा, so it will be r naught square here, and this will be d dot n, because you can write that this unit vector in terms of that and r naught, you can write this as r naught will be equal to r naught. Okay, so use this. So d dot n we have already calculated, that is d cos theta, right? So this will be equal to 1 by r, or you can write here d r naught square, because it's a function of theta here, so r naught square you can take out. This will be minus d sine theta. So this is the this theta component of this electric field intensity, or you can write the total electric field will be equal to, that's r cap er plus theta cap. Okay, or you can write this as, so this will be equal to, E will be equal to r cap into, and what's er? So that's 2d cos theta upon r naught cube theta cap. So finally we have calculated the हमने electric field intensity की निकाला first. We calculate potential at some point p, then we calculate electric field intensity, right? And we have seen also that this if you want to calculate this, for if you use the spherical polar coordinates, you can calculate the field intensity along that theta and phi, and the total field will be